Hey everyone, welcome to Book Overflow. This is the podcast for software engineers by software engineers dedicated to improving our craft by reading the best technical books in the world. I am Carter Morgan, and I'm joined here as always by my co-host Nathan Toups. How are you, Nathan?
I'm doing great. Hey, everybody.
Well, this is a very special episode of Book Overflow. We usually just read the books and discuss them amongst ourselves, but not today. We had the unique pleasure of interviewing Neal Ford, the co-author of Fundamentals of Software Architecture. I had a blast with this conversation. What did you think, Nathan?
Yeah, it was great. Neal's perspectives and Mark Richards' perspectives on this book, you can really see why the book was such a rich experience because both of them bring a lot to the table. And so it was really fun talking to Neal. And we went off and started talking about a bunch of cool AI stuff. And I feel like
Absolutely.
we could have done that for like 3 hours. So that was fun.
His thoughts on AI are fascinating. His thoughts on AI, in particular, how it relates to the future of software architecture, were fascinating. And where it is on his technology radar, which is a concept he talks about in the book, was also great. And he also geeks out towards the end about some sci-fi books he's reading, which is really fun and a treat. We hope you'll stick around for the whole thing. Really such an honor for Neal to come on the podcast. Please enjoy the special episode of Book Overflow as Neal Ford reflects on fundamentals of software architecture. Well, thank you, Neal, for joining us today.
I'm happy to be here. Always happy to talk about something I've written. This is the best part of writing a book, is talking about it after the fact.
There you go. All the hard part's done, and now you just get to talk about it. That's great. And we really like it too, because we did the hard part. We read it. And so now we just get to talk about it. And I guess we wanted to start out, we usually like to ask all the authors, but what inspired you to write Fundamentals of Software Architecture?
It's an interesting question because when Mark and I first sat down and started talking about it, both he and I had a whole bunch of material related to software architecture. We were both speaking at this conference series called No Fluff, Just Stuff, which is kind of a silly name, but it was a tech conference mostly of authors that traveled around the country. And he and I sort of had a casual conversation at some point. It's like, and actually the thing that spawned that was I saw a news story that talked about desirable jobs in the current era. And it was things like nurse practitioner or pharmacist. And I know software architect was always in the top 10. I looked in several different countries. But then I realized, there's a really clear-cut path to not being a pharmacist to being a pharmacist. But there's no real clear-cut path to become a software architect because it's this weird, unique journey. And so I started talking to Mark about that, and it's like, well, what would a book about software architecture look like? And we just both laughed because there's no way you could write all that stuff into a book. It's just too broad. There's too much of it, and on and on and on. But then we started teaching workshops related to the material we had, and we had complementary material. And as we started teaching the workshops in various incarnations, from a half a day to 3 full days, we realized that we were distilling this material down to a reasonable subset of something that you could call the fundamental things that you need to know about software architecture. And after we'd taught that workshop for several years, we ended up writing it down into a book. And in fact, as I'm sure Mark mentioned, we're currently working on the second edition of the Fundamentals book, about 5 years after the first one came out.
We're excited about that. We felt like we got the exclusive scoop. I'm sure we weren't the first people to hear about it, but we were excited.
You may well be, because we've only just started out about ways to make it enticing to people who already have the first edition. So one of the things we're adding is for every one of the style chapters, we're adding a section on how do you govern this style and what are the common risks associated with this style and how do you mitigate those things. So
that's interesting.
A nice addition to each of the style chapters.
You talk about governance, you talk about risk, because that was something I was struck by as I read the book, is all of the kind of weight associated with being a software architect and how much you're responsible for. I'm curious, you say that this comes up on surveys of like the best jobs to have is software architect. Why do you think that is?
Well, it's a highly skilled job. Right now, Mark and I have actually seen a resurgence in interest in this topic because I think a lot of developers start seeing generative AI chewing away at the bottom rungs of the software development world. And, we can't even teach humans how to be effective software architects yet. So there's no way we can teach an LLM how to do that. So I think a lot of developers see that as a way of, escaping that impending problem. But it's the next logical step. You generally have two career paths within organizations. You can either move into management, which a lot of people that are hardcore techies really don't like, or you can keep going up and towards software architecture. So I think that's the appeal for a lot of people who just want to keep building stuff, building a career towards some goal.
That's really cool. The one of the big topics that I loved in the book was that this breadth of knowledge versus depth of knowledge, and how you had to make this transition into doing that. When I've worked with software architects at various companies I've been in, they all seem to have been down a pretty unconventional path. And so is that something that you've noticed as well with the folks that you've worked with?
So much so that when I used to be the MC of the O'Reilly Software Architecture Conference when they did a live conference. And one of the keynotes that we did every conference was this journey talk with a well-known software architect to figure out how they ended up in this place, because we figured out every path is completely different, which is another one of the reasons why it's so hard to actually create any kind of curriculum, or even worse, any kind of certification, because who knows what that would look like. And so it was fascinating because a lot of people who come into the conference were, of course, software architects, and they thought there was some sort of standard path. And what we're illustrating is no, it's pretty much ad hoc in every circumstance. But your point about breadth is exactly right, because what you find is that different people have different breadths for different important parts of the job. And that's, I think, the thing you have to do as a software architect. You can never, like Aristotle, understand everything in the software development ecosystem because it's just happening too fast. But it's important to understand the places where you're weak at, and the places in particular at your current organization where you happen to be weak at. Maybe it's data, maybe it's infrastructure, maybe it's user experience. And so that to me is an opportunity to dip into those places and maybe pair with some of those people and get some more context. And that's how you eventually get breadth, is exposure to lots of different parts of the ecosystem, but lots of different tech stacks too. One of the things that we encourage architects at ThoughtWorks, if they're nominally a Java developer, spend a little bit of time on a .NET project, because the syntax is just details and you can pick that stuff up quickly. But decision processes are often different on different platforms and technology stacks because the constraints are different, and the way things are wired together are different. And seeing all those things is really valuable.
I love what you said about how a lot of software architects have a diverse career path, and there's really no one way to get there. A lot of the engineers I talk to are starting out. Some really have an obsession with like the FANG companies, right? And I think those are great places to work, and there's lots of interesting challenges. But something I always try to communicate to them is there are so many cool, interesting places to work at in this field, and to have your sights set on one company or one particular group of companies it is, I think, not the best way to go. But at the same time, I think you also want to be kind of actively planning your career and making sure you're working on the right things. How do you, in your mind, how do you strike the balance between having a diverse kind of, like, I'm not wording it properly, but having diverse experiences while also maybe not getting stuck in the weeds on something that's not going to benefit your career?
Well, that's a great question, because it is easy to get stuck in the weeds and end up doing something, spending a long time, and or something that you just have no skills for. I mean, user experience design is not a pure technical. It requires aesthetics and taste and some other things that some developers just frankly don't really have much of.
That's me.
You never want me to build a user interface or something, or if you did, you would remark, "Wow, this looks like this was built by a developer," which pretty much was. So I think it's important, but I think it's also important to be really proactive in your career planning, because you can't touch everything as a software architect. So what is the amount of time that would take you to feel like you have enough context to understand it? Because at the end of the day, again, toward the breadth versus depth thing, you don't need a huge amount of depth in these areas. You need enough breadth to help you with trade-off analysis. And that's really where the breadth benefits you from, because understanding all the options when you have to make a decision and understanding some of the nuances of those decisions is really important. I'll go ahead and tell you my favorite ever interview question If you really want to see someone's thought process in real time, of course, if I keep giving this away, then everybody's going to know it. But this is always something I ask when I'm doing an interview for technical skills. And so let's say I'm talking to someone and they say that they're an expert in some language like Java. So what I say to them is, okay, congratulations, you've been made king of Java for a day. And as king, you get to add something to Java that you've always wanted to be there, but you also have to remove something that's always really annoyed you. Go. And I don't even really care what the answer is. I want to see the thought process. Because if you've only ever dealt with Java, you are a deer in headlights. Because you can't imagine adding or removing something, because it is what it is. That's all I've ever used. And so what would you add? But when somebody has had a huge breadth, they'll immediately go into, oh, wow, what checked exception. You got to get rid of checked exceptions. That's annoying. And what would I add? Is it macros? Is it, better flavor? And seeing the thought process is the really important thing there, because that really indicates their breadth, because the more they've been exposed to, the more they will miss the things that they're accustomed to seeing. So those kinds of things give you a better indicator of breadth than, just saying what kind of platforms they've worked on.
That's something I've seen in my career. Is Java was my first programming language in school, and I remember seeing like the memes like, oh, it's a wordy programming language, but it was the only thing I'd ever worked with. And so how could a programming language be shorter? And then you move on to things like Python and totally. You see the verbosity that's present in Java.
But the other benefit, and you've all experienced this as well, is that every language has their own idioms and particular ways to solve problems. And when you work in that language, you bring those idioms back to your native language. The famous K&R C book, of course, instructed people about how to write in C, but the main thing it showed was how to write idiomatic C. And that it was a style guide plus a language guide. And that was a huge influence on the C community. And it influenced the way people wrote C code from the day it came out until today, because it was, a combination of those two things. It had such good idioms in it, and really showed off the power of C.
Yeah, that's really cool. Speaking of the rapid pace of change, when did you start working on when did you start working on this book before it was published? It was published in 2020, is that correct?
Yes, early 2020 is when it was published.
Okay.
Well, we started teaching the workshops. We actually recorded a streaming video in 2015 of this material.
Wow.
Which means that we've been teaching the workshops live probably since 2013 or 2014. So we had worked on this material, filtering and refining, et cetera, for almost a decade, probably 7 years from when our first conversation happened. We actually recorded a couple of videos, a version 1 and then a second edition of the videos, because when we first started talking about this, the big thing at O'Reilly at the time was streaming videos rather than instructor-led classes. And so they really wanted. And so the first iteration of this material was actually 12 hours worth of streaming video. It's still available on the O'Reilly platform, but of course it's a bit out of date now since it's 10 years old now.
That's amazing though, because this book, has really great coverage of a lot of the different architecture types and the trade-offs, right? I think a big theme in this book is that you want these least worst design or least worst architecture, and that everything is a trade-off. Like there's a big themes. This was written during the rise of Kubernetes and container orchestration, and you could already see this, right? It was in the output of the book. Did that feel like a moving target while you were working on this?
No, because the book I wrote immediately before this book was building evolutionary architectures. And so I'm used to this idea that it's a constantly evolving ecosystem, and you're always trying to hit a moving target. I'm actually, one of the things that I'm quite proud of in our book actually is how well it has aged, given how fast all this ecosystem changes. But that's very intentional. You'll notice that there's actually very little source code in our book, because every line of source code you put in a technical book halves its shelf life. Having written a whole bunch of technical books that are very source code heavy, I know exactly the problem of doing that. And we were literally targeting, when we wrote this book, we want this IP to be good for at least 5 years and hopefully maybe 10 years. And that was our goal. And so that's what we were really shooting for. And I think we hit a good level of abstraction. In fact, I think one of the reasons I think our book is re- relatively successful in this space is I think we hit a level of abstraction that people have struggled with in the past, because it's either too low level and in the weeds and too code centric, or so in the clouds that it's hard to apply it to the real world. And we're sort of in the middle there at the component abstraction level of architecture, but not in too many details, but not too abstract. We actually struggle with that a little bit more in our software architecture, the hard parts book. I know that's not the topic of this particular podcast, but in our hard parts book, we realize, because and this is something that slowly we've grown to realize over time, is that when you talk about purely architectural things, it's too abstract and everything is obvious in hindsight. So you get a lot of, oh yeah, of course that's true. But then when you get people to actually apply these trade-off analyses, that's when it gets interesting and challenging. And so we realized in our hard parts book, which is all these difficult problems in architecture, it's very abstract. And so we invented a mechanism called the SysOps squad. It weaves through the hard parts story. It's this mythical company that's having all these problems in their architecture. And for every abstract thing we talk about one way that the SysOps squad solved this problem, but it makes it a lot more concrete, which I think helps people a lot without going all the way down to source code, but one level of abstraction closer to a real problem, I think, allows you to apply the trade-offs. All of our workshops also have hands-on exercises, and that's the most valuable part, of course, because applying the things that you've just talked about right away is the best way to learn about those things.
Speaking of the hands-on exercises, we love the idea of the architecture, and this is a word I've only read, but is it katas?
Yep. Mm-hmm.
Yeah, katas. We love that idea, and that's something we like to do at the end of every episode of our podcast. Talk about what are we going to do differently in our careers as a result of having read this book. And that was something that I took away. I'm like, I'd love to kind of do an architecture kata at my company or with my team. What would your advice be for someone? I know you talk about this in the book, but it's great to hear from the horse's mouth too. Someone who's just read the book and is going to implement their very first architecture kata. What would be your advice starting out?
Well, I would find a few people so that you can have discussions / arguments about with the trade-offs, because that's really the essence of what you're doing there. But I find a small problem. We have a bunch of them on the fundamentals of softwarearchitecture.com website. We have a whole bunch of katas there. So find a problem and then start working through the trade-off analysis. And follow the basic outline. We had in our book do an architecture characteristics analysis, do a logical component analysis, and then choose an appropriate architecture style. The tricky thing, of course, is how do you grade it when it's done? And this is also one of the insights that we ended up with in our book, is when we first started doing our hands-on workshops, we thought a clever idea would be to take all these kata outputs from teams and take pictures of them, because we're having them sketch them on paper or whiteboards, and create a catalog of these things, and would have this whole catalog of kata solutions. And we did that for half a year and then realized it was pretty much useless, because you could see how the team had solved the problem, but you didn't see the why. Which of course became our second law. And we weren't forcing these teams to actually write out formal ADRs or architecture decision records as to why they made these decisions. And we realized it was half the story. And when you could look at lines and boxes all day, and even really experienced architects, when you look at an existing system, I can tell you how it works. But there's some decisions it's like, I don't know why they chose that versus this other thing, because you don't have the context that they had, especially if they haven't documented it and written it down. And so that, I think, is the real key, is finding someone like an architect in your organization or someone with experience that can come and actually grade it for you and tell you, here are the trade-offs that you found correctly, here are the ones that you might have missed. And rather than trying to create some sort of answer key, the process is really the important thing. So even if you don't have somebody to grade it, going through the process yourself, the activity is the really important.
That's great. So obviously this book is really useful for anyone who wants to be on the software architecture trajectory. Who else do you think this book would be useful for as far as having a conversation in an organization? And I ask this because there's a lot of focus on collaboration and on communication, especially towards the end of the book.
It's a great question. And we've actually been surprised at how many non-developers have been reading our book. The other thing we've been completely shocked by is how many people listen to it as an audiobook. Frankly,
Really?
cannot imagine doing that, but there's a huge number of sales in the audiobook for this thing. So I still haven't quite puzzled that out and how they're doing the diagrams in the audiobook. But
Didn't you do that, Nathan?
I used both. So
okay.
actually, it was the first the first two sections of the book I read.
Okay.
But the final section, I needed to do some yard work, and I was like, oh yeah, actually, I had bought the audiobook like a year and a half ago and hadn't listened to it. And so I was really happy to put it to use. And actually, the third section was,
yeah, the third section makes sense because it's
was
a
great.
lot less technical. It's soft skill stuff. But we've actually found a lot of it's at the right level of abstraction. So a lot of project managers are actually reading because they want to know what are architects doing. You know, this mysterious software architecture thing that they look like they're working and having meetings, but I don't know what they're doing. So, you know, even if you just kind of skim it to get the overall structural design process in place, I think that's useful. And, you know, manager types have been reading it to get a kind of an overview. Um, so we've been actually surprised that the audience is broader than just hardcore techies. And I think the lack of, you know, drowning in source code probably helps that as well because it stays at an abstraction level that you can consume without being too technical.
We love the focus on technical breadth. You can imagine as two guys who decided to start a podcast where they read a new book each week. We're big to breadth guys here. But obviously, and this is something we talk about on the podcast too, you can't gain all of your experience just from reading. You've got to
Yep.
implement and do. But at the same time, there's only so many hours in a day. And, you know, it's not like you can just say, every day this week, I'm going to work on a new technology. At a certain point, you got to build stuff for the business. What do you think is that balance between encountering new ideas from either reading books or blog posts or videos and then actually doing?
So did Mark describe the 20-minute rule when he was on here?
No, but we talked about it in the podcast, I think. We loved it because we found anecdotally that's what we need to do, about 30 minutes a day to keep to at least read the books.
Yep, that's a great way to do it. I mean, partitioning your time. So one of the things that you discover as a software architect is there's never enough time to do all the stuff, particularly if you also have this life thing that you're doing, because part of your mandate as a software architect is learn enough about the new stuff that's coming down the pike to be able to make reasonable decisions about it. And, you know, as we know, the software development ecosystem is not slowing down at all and continues to accelerate. So I think a lot of it. So one of the things that I talk a lot about to architects that I'm coaching within ThoughtWorks is get really, and this is another one of those soft skills, get really good at personal information management, scheduling, prioritization. There's this thing in the Covey information management world about and they actually put together this quadrant of things that it's a matrix of things of urgency and importance. And obviously, urgent and important things you'll handle right away. But there are a lot of things that are important that are not urgent. And those tend to fall off your schedule, particularly when you have a busy schedule. So basically, the whole Covey planning process is how do I address those important but not urgent things and avoid the urgent but not important things, which also come up constantly during your day that you need to be able to swat away. And so it's really about prioritizing your time, because one thing that universally is true for software architects is they never have enough time to do all the stuff they're trying to do. They're trying to wear a technical hat, they're trying to wear a team hat, and then a project hat, and an ecosystem hat. And so being really good at prioritizing and dealing with your time. One of the things that I'm adamant about, which is very difficult, is inbox zero. Your inbox is the worst to-do list on earth. And so use a better system, get it out of your inbox and into some sort of coherent system like Getting Things Done or one of those information systems. So I actually think that's an important recipe for success as an architect, is to get good at personal information management and resource management, about knowledge. I remember reading this thing about Kubernetes and not supporting something, but what was it? I got to be able to find that thing. And so being able to consume information, but then capture it in a way that you can get back to it, I think is really, really important. A lot of architects play around with, I don't know if you've heard the term or familiar with a Zettelkasten, or the Zettelkasten note-taking technique. tools like Obsidian or what's the other one? Seek. Log-Seek are tools that implement this Zettelkasting note-taking technique, which is sort of like a mind map on steroids. You know, mind map, you build hierarchies, but then you build cross-cutting links between things. In a Zettelkasten, you're forced to name the relationship, but then it allows you to revolve around the relationships and see linkages between things really effectively. And that's something that architects have to do all the time. And so a lot of architects I know are using the Zettelkasting note-taking technique, which actually comes from the 1800s, but there's a lot of technology that supports that now. So things like that, I think, are important for success, because you need time to be able to do all the things that you've agreed to do as part of your job.
I've been shocked in this career as you progress how much of it is executive functioning.
Absolutely. I wrote a book. My book 4 or 5 books ago was called The Productive Programmer. It used to frustrate me a lot when I would watch people, when I was doing training classes, particularly programming classes, and I would see developers do these just cringy things like, I need to move the cursor one row up and one column over, and then pick up their mouse and then carefully position the cursor where they wanted it. And I wanted to smack their hand and just tell them to use the arrow keys. We used to make a joke that too many developers were walking their computers instead of running their computers. And that drove me crazy, because, I mean, if you can't type, if you don't know how to use a computer, you're not going to be very effective as a software architect. And so I'm really adamant about productivity too, of not wasting time on your computer. It's been a sub hobby of mine for a few decades since I wrote that book, because it drives me crazy. I mean, developers that don't know shell commands, come on, shell commands are incredibly powerful. Yeah, it's kind of arcane, but now with AI, you don't even have to understand all the magic syntax. Just tell the AI, hey, I need a shell command to do this stuff, and you'll be amazed at what it'll produce for you. So just things like that. You know, at the end of the day, you're trying to cram a lot of clowns into this car, which is your career and your time of day. The more efficiently you can pack clowns in the car, the better off you're going to be, and the more clowns you can pack in the car. So that's really about, just raw productivity with tools that you have and your own personal processes. How do you manage mail? How do you manage information retrieval? How do you manage the things that you need to track in your career? So you should always have a ready list of things that I need to learn more about next, so that anytime you have a chance to learn about something new, you're not fumbling around. You know exactly what to go to get.
This makes me also think about the fact that, most architects are not in a position of authority, right? They're not a boss or a manager of folks, and yet they demonstrate leadership. And I think there's a lot of examples of how to demonstrate leadership.
Mm-hmm.
I'd love to know if you could elaborate on that a bit more, because it felt like such a powerful subject in the book.
It is, and it's one of the things that it's hard to learn, because it's one of the trickiest things to do. One of the things that I think is very good that ThoughtWorks does for our projects is that our architects and project managers are peers. One doesn't work for the other one. And that's really valuable, because inevitably there's going to be tension about schedule pressure versus technical debt versus something like that. And there needs to be a conversation between peers there. It doesn't need to be a constant conversation about, we're building huge technical debt. Yeah, I know, but we have to make this release, so just suck it up. Over a long period of time, we all know that's going to lead to a disaster. So there needs to be the ability for an architect to be able to negotiate with people like project managers or enterprise architects or people like that who are going to be affected by these decisions. And, there needs to be some sort of compromise reached there. And that's just one aspect of leadership. The other thing that you have to do, and I had to learn this very much the hard way, is manage disputes around technical issues. I famously had a project that had just a fundamental difference of opinion about how to handle some core thing in the architecture. And these two factions were never going to agree. And so I heard them out and then made a decision. But inevitably, every single time, one of the disadvantages of the approach we had taken showed up, they were quite vocal in pointing it out, and I had to tell them, we understood it was a trade-off, but you can keep crowing about that if you want to, that you think we made the wrong decision, but I think we made the right decision. So not letting that kind of stuff get under your skin, because it's, inevitably people will do that. So, having a step distance away from those kind of interpersonal things, I think helps a lot from a leadership standpoint. And I think, unfortunately, what that tends to do is isolate architects and other people in leadership roles from teams because of that dynamic sometimes. So I think it's useful if you can create an ecosystem where that sort of thing does not create toxicity. I used to have a project manager who came to me. I was the architect, and it was that same project, in fact. And she came to me and she said, "Really, the developers in this team really seem to argue a lot." And I said, "Argue? We never argue. We have impassioned conversations." There's a big difference between that, because nobody's mad about anything. We're not arguing. There's no heat there, but we're very strongly trying to advocate for a position that we think is the correct one. And she viewed that as, argument and anger and ire. And it's like, no, it's not at all. We're just super, interested in technology and trying to advocate for it. So understanding that distinction, I think, is also important.
Yeah, I stole this from someone, and I'm not sure who, but it's I like to have strong opinions loosely held.
Yep.
You stole that from me.
Did I?
Yeah, it's the company I work at is a big believer in that.
That's so funny. Yeah, well, I've been hanging out with you too much, so yeah. I call myself a recovering contrarian, because I that's definitely my knee-jerk reaction, but I'm learning the soft skills of not immediately going there. It's a superpower. I do think, like, being willing to take an opposing view is great, but if you do it too often, obviously it's terrible.
Well, and we joke always that they're called soft skills, but we always put them into air quotes because it's the most difficult thing most technologists suffer, because it's not the thing that got you to be a software architect. It was technical expertise and and good technical depth. And now suddenly, well, you're such a great developer, you make a great manager. Like, what? So it's definitely a skill set. It's learnable for sure, but it definitely takes time to learn it. And it helps too if you have a team that realizes you're learning and can gently walk you through the learning process rather than slam you into a wall.
So speaking of collaboration and peers, you co-authored this book with Mark Richards.
Mm-hmm.
I would love to know, were there any part of your process in which you had disagreements or that led to better outcomes, and what your process is of working with each other?
Yep. Mark is a fantastic co-author, which is why I've written so many books with him and continue to write books with him. I've had various experiences with co-authors, particularly because, almost universally people who are writing technical books, it's not their day job. So it's, at least one of the other jobs that they have outside their day job. But Mark and I have the attitude that we tend to take the lead on a particular chapter. We partition them up. But then as soon as one of us finishes, the other one reads it. And we actually stole this mantra from Prag Dave and Andy Hunt, the Pragmatic Programmer authors, that each of us reads a chapter as if we had written it ourselves, and anything that we see that we don't think is right or as good as it could be, we change it, and then we pass it to the next one. And we keep doing that until we come back with a round of that, and there are no diffs, and nothing's been changed. So it is very collaborative. We have a lot of discussions, particularly for things like the star chart ratings for all the architecture styles. We had a lot of discussions coming around to, what the actual values for those things are. But Mark is a great collaborator, so, it was very easy to do. He's also a maniac productive writer. So anytime you're writing a book with him, you're having to run as fast as you can to keep up with him when he's writing stuff. But our two styles work really well together. He's writing books together with other people's hard, but I keep doing it because I generally believe that the sum is greater than the parts. That when you do really good collaboration, I'm a huge fan of pair programming as well. I'm a huge advocate of pair programming being ThoughtWorks, and I've seen in real time that it produces better results, and same is true for collaborating on books. Which I feel compelled to talk about something that I've been doing on projects around software architects and pair programming. pair programming is a great practice because you're basically doing real-time code reviews and real-time hardening your design as you do it. But paired architects is a nightmare because you're 50-50. So, the rule in pair programming is no discussion longer than 15 minutes without typing. You end up in a design discussion that lasts longer than 15 minutes, you're supposed to go find a tech lead or an architect and get them to resolve it so you can get to typing again. If you're the architect, who are you appealing to? And if you're a pair, then it's 50-50 split. So what we have actually found, and we've implemented this on some of our projects that are big enough for this, so the thing that architects always need are peers. Knowledgeable peers that they can bounce questions off of and get advice from, etc. So I've created this idea of an architecture triad. Instead of pair, it's 3 architects that work independently all week on projects, but meet. Some projects I know meet once a week. One project I know they meet twice a week. And the other 2 architects in the triad are working on other projects, but they know enough context of the project you're working on, so they're a good sounding board for advice. Hey, what should I do? They help you walk through trade-off analysis. And the beautiful thing is because there's always 3 of them, there's always a 2/3 majority. And there's never a deadlock. So that helps you get informed advice from another experienced architect without reaching some sort of deadlock situation. So I think that's a great way to collaborate with architects in a large organization, create triads around related projects and have them collaborate much more intensely than they normally would and act as a sounding board and a way to come to better decisions.
You talk about wanting to stay current, and you talk about your technology radar. We loved that. So I want to talk kind of about your personal technology radar. Is there anything you're seeing happening in the software engineering world right now that you're particularly excited about or optimistic about? What cool developments are kind of on your radar right now?
Well, I've heard talk of this thing called AI that everybody seems to be all excited about. Yeah, of course, AI is the big tectonic shift that's happening in the software development ecosystem right now. And we're super fascinated. The thing that we're actually, you mentioned the ThoughtWorks Technology Radar. We just produced one of those several months ago. We're going to produce another one in September, which will be out in October. Fully a third of the blips on our radar were AI related. One way or another in this most recent radar. So it's obviously pervading software development ecosystem. We're actually more interested in the second order effects versus the primary effects. Things like ChatGPT and the Devon programming assistants and those kind of things are kind of obvious augmentations. But we're looking at other parts in the software development ecosystem that can benefit from this. Things like QA or business analysis. A lot of our business analysts are using it for gap analysis. Okay, here are these things I figured out. What am I missing here? And, a lot of the suggestions don't make sense, but every once in a while, one of the suggestions is really, hey, that's right, we did not take that into account. What I think is going to be fascinating about the AI stuff is not the primary stuff, but the secondary and side effect stuff. And I'll give you a great example of that. One of the things that we talked about on 2 editions of our radar ago is a warning that we put on a technique, which are a package dependency validation for hallucinated dependencies. So here's the scenario. I'm a developer and I'm using ChatGPT to generate some code for me for something like React, let's say. And ChatGPT, being as helpful as it possibly can be, will hallucinate a package dependency for you. Well, what if a nefarious actor notices that every time somebody builds a React application this way, it hallucinates the same package dependency? So I'll put some malicious code and make that a real dependency, and they'll pull that malicious code into their project through that dependency that ChatGPT generated for their project. And so our warning is you really need a mechanism like Dependabot or Snyk or one of these software supply chain tools that validates your dependencies on projects to avoid hallucinated dependencies that don't point where you think they do. And, the software bill of materials stuff is extremely important on projects right now. This actually goes back to the evolutionary architecture stuff I was talking about before, because the Log4j thing that happened, about a year and a half ago, because a lot of adults went to software architects and organizations and said, tell me how many of these systems are running this piece of software. And the architects went, I don't know, probably a bunch of them. It's a nightmare, isn't it? And they were like, that is not a good answer to that question. We need to know some of those things, and that's going to get increasingly worse because the attack vectors are not only going to sprout, but the speed that they're going to be able to work is going to speed up. And so automation around governance is critically important. We have now reached a point in software ecosystems where manual processes cannot work. We have software systems that are hundreds of thousands or millions of tiny moving parts. No human can possibly govern all of that. You need automated mechanisms to help you govern the things that you can automate. You can't automate everything, but there's a huge amount of it you can automate, and I think we're going to need to do more and more of that. So this is actually related to the building evolutionary architecture stuff, but I'm spending a lot of time now thinking about what if the role of software developer very quickly becomes refactoring generated code more than writing code. And how do you build guardrails on generated code? One of my predictions is that we're soon about to see a tsunami of working but terrible code. Because the way AI fixes things is with brute force. But brute force doesn't do good abstractions. One of the observations we made in our last radar meeting is our colleagues in China have been doing a lot of work on trying to get AI to generate complete applications. And what they've realized is AI has a much easier time generating a ball of mud without good abstractions like model view controller. And if you just want something that's a simple throwaway, then great, brute force it and let it do its thing. But if you're trying to build a foundation for something for the future, you're going to take that brute force code and refactor it into properly structured code. And I think that's where the skill, both the automation around that and the skill of developers, I believe that the refactoring menu option on IDEs is going to start getting a whole lot more use now than it did 2 years ago, because we're going to start doing a whole lot of refactoring generated code, certainly in the near term. And so I'm really interested in the internal quality impacts that AI generated code is going to have, and how do you write governance mechanisms for that, and a bunch of these other ecosystem concerns, which are sort of the second order, third order effect from the obvious things in AI.
AI is so fascinating, and especially when you talk about code generation, because I think it really strikes at the heart of how we think of ourselves as software engineers, because that's what we do. We write code. Mm-hmm. But I think it really is just another abstraction, right? I think you go back 20 years and I don't know, for example, when I upload my Python file to a Lambda in AWS, do I know exactly how that's all executing under the hood? Not really. I have an idea of the fundamentals, but it's funny, just we keep kind of moving further and further up the abstraction tree, and who knows how far we'll keep going.
That's a great observation, but I'll tell you one place where I think it's flawed. And this is somebody told me, because I have my abstraction the same way as spreadsheets. So in 1970, accountants spend more than half their day manually recalculating paper spreadsheets with calculators and adding machines, which is why they flipped out when spreadsheets came out. Accountants literally went into computer stores and said, I want that spreadsheet software and whatever computer it runs on. I don't care. I've got to have that, because it was such a powerful thing. And so two things happened. Immediately, financial models got way more complicated and sophisticated, because they could be. And by 1980, if you were an accountant who didn't know how to use a spreadsheet, you couldn't get a job. That doesn't make you a better accountant. It just takes away the busy work. And that's exactly what you're talking about from a development standpoint, raising these levels of abstraction, because you could write everything in your ecosystem in raw Java bytecode if you wanted to, but it would take you forever. I'd much rather have a Java compiler produce that bytecode. But here's where the analogy fails. And my colleague, Brigitte Berkele, who's spending a lot of time in this AI space, is the one who explained where my metaphor here with the spreadsheet is flawed. The beautiful thing about Java bytecode or spreadsheets is that it's a clean abstraction translation from one level to the other. We're just simplifying the abstraction. But it's fundamentally different in LLMs, because if I ask it to produce a solution this time, it may produce a different solution next time. They both may work, but they'll be different solutions. So there's a non-determinism in the AI world that we did not have in the normal kind of escalating abstraction levels. But here's an interesting thought experiment for you toward that end. This is something I've been thinking about for a while. If I could write a set of architecture fitness functions that describe the capabilities of the code that I want and its behavior and hand that to an LLM, and the code it produces meets all of those capabilities, all the characteristics, and it does the behavior that I want, that I can verify through testing, do I really care what that code looks like? It could be Java bytecode, it could be Python, it could be R. Who knows? Do I really care? If I can validate, so it's getting to this, how black box is the black box. Could we get to a point where I can build, here are the guardrails, here's the behavior I want, produce code that matches the guardrails, stays within the guardrails, and does what I want? I don't actually care how you've implemented it. We may, at some point, that may be the next level of abstraction that we start thinking about, is I don't really care about how the internals work. But of course, that just means we need to get much more precise in being able to define what kind of behavior do I want and what kind of architecture characteristics do I need to support. If we can get really precise with those things, then I think we can actually start operating at a much higher level of abstraction of just specifying the kinds of things we want, and not worry as much about the implementation. And in fact, if we don't like this implementation, tell it to generate it again. We'll get a different implementation. So I think you're right. We are operating a different level of abstraction, but this one is a little bit fundamentally different because of the non-determinism, which I think is fascinating.
I've found that using these coding assistant tools work best for me when it's an area that I do have expertise, but there's some grunt work. So I can edit. I can go in and go, I was doing this recently. I was playing with something and it auto-generated some Go code. I write a lot of Go code.
Mhm.
And it used the math random library. And you almost never want to use that unless you're doing statistical stuff where you have a seed that wants to give you determinism in your randomness.
Mhm.
Most of the time you want the crypto random. And if I looked at it and I was like, if I didn't know what I was doing, I would very easily have put a very unsafe random number generator in this function, but at the same time, I thought of this as like, oh, an intern could have also done this, right? An intern could have I have asked them to go do a thing and they picked the wrong thing. And then I would give them some editing notes. And that's where a lot of that is helpful. When I'm most ignorant is when I make the biggest mistakes with these large language models.
I tell you, so I actually was alarmed when I learned that a lot of universities are teaching Java as the first language. Because if you take someone who's only ever done Java and you stick them on a C or C++ project, they are actively a chaos agent on that project. You're going to have memory leaks that you've never seen before, and it's going to be a total train wreck because you just don't know. I mean, it's all been taken care of for me before. So exactly to your point. But I think that's where the utility of this comes in. So I mentioned things like Z-Shell before. I mean, Z-Shell has a tremendous amount of arcana that I have not memorized. I kind of know that behavior's there. I haven't memorized the syntax for it. But that's exactly where the sweet spot for LLMs are, because at the end of the day, it is, various terms for it, the stochastic parrot, the super energized regular expression engine. What a LLM is going to give you is a statistically likely answer to your question. May not be correct, but it's statistically likely. It just turns out that most statistically likely answers are also correct answers, but not always. So that's why it still requires some level of expertise to know what kind of library to use, because, hey, you're lucky it actually picked an existing library. It could have just hallucinated a library that generates random numbers. The code wouldn't even build in that case. So we're still at, but for a lot of the AI stuff, particularly around software development and absolutely around things like architecture, we are very much at what I call the talking dog stage. It's amazing that there's a talking dog. The dog talks gibberish, but hey, he's talking. It's amazing. Look, it's a talking dog. And a lot of the AI stuff right now is the talking dog stage. It's like, wow, look at that stupid trick that it did, but it's not very useful yet. So I think that's the next level of refinement, is figuring out how to make it actually useful and keep it from making the fundamental kind of mistakes you were talking about, which, an experienced developer would spot right away. Try to, add more nuance to that decision process.
As someone who has an ironic appreciation for the Air Bud franchise, I love the idea of a dog playing sports and building a whole franchise around that. I love it so much to the point that, like, I have a bookshelf in my home, and like hidden amongst it is a VHS copy of Air Bud as like a joke. Anyhow, the idea of of a large language model as a talking
So what's
dog.
the name? There
cracks
was
me up.
a movie back in the 80s, I think. I can't remember the name of it now, but it was a mule that was a kicker for a football team.
Oh.
And the whole point of the story is that, well, there's nowhere in the rule that says you can't have a mule as a kicker. So that was the whole point of the movie. And so this mule became a football kicker. So if you like sports and animals.
That's great. We read Stephen Wolfram. We read his book, but I think it's just 2 essays on his website. It's called "What is ChatGPT Doing and Why Does It Work?" That was really, it was great to kind of to take a peek back, and we had a conversation with Brian Kernighan the other day about what's the level between how much you trust the abstraction and how much do you want to understand how it works. And reading that book and getting a little bit past the abstraction to how large language models works was fascinating. In particular, they talk about the temperature parameter, which kind of contributes to that non-determinism. I don't know. Do you think there will be because you could imagine a world, right, where you ratchet the temperature parameter up to say, just always give me the next most likely token. Don't mix it up at all. And you could create a completely deterministic AI agent. Granted, it'd be less creative. I don't know. Do you think something like that in software would be useful?
I think it would be, because we're always dealing with very constrained kind of context. So my first major was actually journalism before I gradually wound my way around to computer science. So I think that's where all the writing came from. But at some point, I compared programming languages to highly structured poetry that's graded by a compiler. I mean, it's a language. I mean, we literally call them languages. They're a way to express ideas. And so I think that what's going to happen is our programming languages are going to grow toward the AIs, rather than the AIs gets better at our programming languages, because our programming languages are very much centered toward humans typing code into a terminal, basically. I mean, source code after all this time is still text. How long has it been pure text? I mean, we're coming up on 100 years now where it's been ASCII or something similar to text as a representation. So I think we're going to grow more toward the kind of AI abstractions. But a lot of it's going to be things like RAG, of creating a much narrower context for figuring out what you're trying to produce here, tuning an LLM for the purposes of code generation within a particular narrow problem domain. That's actually been a lot of the work we've been doing in the AI space, is creating specialized LLMs in areas that you either can't use a public one because of trade secrets or privacy concerns, but also for things like pharmaceutical development. That's a highly, highly technical but constrained kind of ecosystem to work in. And so tuning your LLM very narrowly toward that goal will tend to get you higher level or higher quality results. So I think we'll see a lot of specialization around that in the near future.
It makes me wonder too, taking this architecture triad or that you'd had, I wonder if you could have this like sort of diversity of perspective large language model, and maybe one of them being like a fact checker. Like did the thing that came generated, is it factually correct? Is it provably correct? But then also have a couple of perspectives there. That'd be interesting.
It's interesting that you mentioned that, because one of the patterns, so one of the things that we talk about in our most recent radar are emerging patterns for LLMs. And one of the patterns that we've seen emerge in South America from some of our clients is using a higher priced LLM to check the quality of the output of a cheaper LLM.
Interesting.
So the big commercial ones are very expensive to run. So run an internal one and produce the results, and then use the expensive LLM to spot check your results to see how good they are. That's exactly what Nathan is talking about, is some sort of mechanism like that.
That's fascinating.
Using the LLMs to check the other LLMs. But of course, that's what's going to lead to Skynet as they start chatting together and figuring this stuff out. So.
It's an LLM consensus algorithm that
I did some freelance work for a little hospitality company, and it's not exactly, it was all natural language parsing, but not LLMs. They were using Amazon Lex for simple, they had like a chatbot. And so when you provide like a chatbot to a hotel, obviously if someone asks like, what time does the pool open? You don't want to just throw that to an LLM, right? Yep. Because it'll hallucinate. So they're using Lex to kind of finely control that. But they were finding that guests weren't interacting with it in small single questions like that. Guests were often getting like the welcome text, like, "Hey, welcome to the hotel," and they're saying, "Great, super excited to be here. What time does the pool open? Also, can I get an early checkout? And is my dog allowed in the properties?" But then you throw that to the Amazon Lex, natural language processing model, doesn't know what to do with it, can't match it to a particular intent. So they fed it to ChatGPT first and said, "Hey, break this into the individual questions," and then fed those individually into Lex. But I thought that was an interesting combination of the two, where you get the cheaper processing of Lex and also the more finely controlled processing, but then for the ambiguities, bringing out ChatGPT. I'm curious to see. Yeah, I don't know what the future looks like, but I imagine we'll start to see large language models married with existing tools like that more often.
A perfect example of what we called out on our radar, emerging patterns for LLMs. Because this is a new part of the software development ecosystem. What do? We create patterns and anti-patterns around common problems, contextualized problems, and how to solve them. So I think there's going to be a cottage industry of patterns and anti-patterns books for interacting with LLMs for software development coming up very shortly. But those are two good examples of, I'm sure there are lots more.
So as Carter likes to say, we're a book club.
I say we're a book club masquerading as a podcast.
So it's important to us to know what you're reading or what you recommend to others. So I would love to know, is there a book or a set of books that you've been finding yourself recommending to others to read recently?
And we also like to say, even if it's fiction or nonfiction, obviously technical books are great, but just anything you're reading, we always like to know.
So mostly what I've been reading over the last couple of years, actually, I've fallen down sort of a rabbit hole of composer biographies, particularly opera composer biographies, because I'm a huge fan of opera. And so I'm really fascinated by the creative process. And so there are several books that are out about deep dives into how a composer worked with their librettists to come up with the things that we now know as their operas. So there's a lot of stuff about creative process. I really love. There's a little subgenre of books about books by writers about writing. And I love those books. Stephen King's best book by far is his book on writing, which is a phenomenally good book. I point to people, if you've never read it, you should go get a copy of it right now. You can read it on a single airplane. It's called The War of Art, The War for Art, by Stephen Pressfield.
Oh, Pressfield's
great. Very thin book. I actually have some copies here that I hand out to people that have never read it. But he's a novelist who wrote and tried to get published for more than a decade and kept getting rejected and kept at it and eventually produced the Pulitzer Prize winning Legend of Bagger Vance. So he is a paragon of determinism, of not giving up. And that book is really a lot of advice about how to not give up on stuff like that. That's always a book that I recommend to people. I've been reading a lot of stuff, deep dive stuff on large language models, and been doing some research on that just to understand more. And I'm a technologist at heart, so I like to peel back layers of abstraction and figure out how stuff like that works. And so been doing some reading on that. And the other thing I've been reading, because I do like to keep reading some novels, so I don't know if you're familiar with Ian Ink's Culture series of science fiction novels. It's so good. He wrote, I think, 8 books in the 80s and 90s. He was a mystery writer, but he also wrote science fiction. It was Ian Banks, the mystery writer, but Ian Ink's the science fiction writer. And he created The Culture, which is a super advanced AI-driven society. And none of the books are related to one another, but they all take place in that same mythology.
Oh, interesting.
And they are so, so good. In fact, I've read 7 of the 8. And I haven't read the last one yet, because when I read that, there won't be any more culture books left. And so to avoid that problem, what I've done is gone back and started rereading from the beginning. And I'm rereading them again to get back up to 8, and then I'll finish it off at 8. So, but that's been a pure delight, because they are so, so good, so well written, and so imaginative. The third one in the series, The Use of Weapons, is actually told in 2 directions, forward and backwards, sort of like the movie Memento.
Mm-hmm.
And it's absolutely fascinating how it works and the way he manages to put it together. So It's well worth reading.
I'll have to check those out. One of my favorite books is World War Z, and one thing I love about it is how it doesn't focus on any one particular character, but rather tells this overarching story. I love any book where it's almost like the world is more interesting than the characters. So that sounds fascinating. These 8 books in the same
love
world.
these.
Okay.
So most of the culture is a super advanced civilization, and most of the characters are part of what they call special circumstances, which is basically their CIA, because they're dealing with these other cultures, not the culture, these other civilizations, and having wars with them. And so some of it is sort of, there's a philosophical ideal in the culture, and then there's a reality of how they have to apply that. So that's a lot of the tension, and it's so.
I'll have to check that out. That sounds great. Well, Neal, thanks so much for joining us today. We really do appreciate your time. Is there anything you'd like to leave with our listeners before we sign off?
No, nothing in particular. Mark and I are working on a second edition of the Fundamentals book, so we're should have that done before long. And we're actually working on material for what we're calling book.next, which we don't know exactly what that's going to be yet, but we're starting to get some ideas for that. So we're very excited. That's one of the funnest parts of the book writing process, is figuring out what the next thing's going to be. So stay tuned.
Well, we will definitely read the second edition, and I'm sure we'll read anything else you have. We were a little nervous when we started this podcast. We were like, are we going to run out of material? No, we are never going to run out of material. There's so much stuff to read.
If you ever find yourself being tempted to run out of material, go back and read Fred Brooks' Mythical Man Month.
Yes. Brian Kernighan recommended that the other day too.
It's
in our backlog. Book. I snuck it in there. So
yeah.
Also, your Evolutionary Architectures book is in there as well. So
great. Yeah, fantastic. That's another one I would recommend for sure. Toward this idea of soft skills for architects, I wrote a book several books ago called Presentation Patterns, which is a Gang of 4 patterns, anti-patterns approach, but doing technical presentations based on all my experiences speaking at conferences and that kind of stuff. So if you're trying to up your presentation game for, sales presentations or technical presentations, there's a book out there for that too.
I mentioned it to Mark Richards, so I wanted to mention it to you. Have you ever read Made to Stick by Chip and Dan Heath?
Yep, I have.
Okay, that's a great one. I really enjoyed that too. Well, thanks so much for joining us today, Neal. Thanks, listeners, for tuning in. You can find us on Twitter at Book Overflow Pod. You can find us on YouTube, also at Book Overflow Pod, and on any major podcasting player. So share with friends, leave a 5-star review, comment. I love hearing from our listeners. Thanks, everyone, and have a great day.
Thanks for having me.